So we will look at practical electricity MCQs. Number 1. So if you want to connect a lamp, where would you place the fuse and the switch? So we know that the fuse always goes on the live wire, so does the switch, because if any of them is disconnected, the lamp should be disconnected from the mains, and that's why we have this one, right choice. Number 2, what's the error in the diagram? So this part of the cable should be under this clip. Why? So that it secures the cable. Every other thing seems fine. We have earth going to the earth pin. We have neutral wire connected to the neutral pin, and we have the live wire connected to one end of the fuse, and the other end, the fuse here will be connected to the pin. 3, convert the 100 volts into kilowatts, that will be 0.1 kilowatt. Run it for 5 hours, 0.5 kilowatt hours, multiply 0.24 should give you $2.52. So on this plate, this level, what is the frequency? It is this one, 50 hertz. Again, the same question, which one is correctly wired? So we have lamp, we have fuse, we have switch. 1 kilowatt, how much it costs? 2 kilowatt for 3 hours, 2 times 3, 6 kilowatt hours times 0.24 gives you 1.4. So we have the phrase, if you remember, bar rinse out your greasy bottles. Very good. What? You have to use these numbers and calculate the resistance of this resistor. The first one is yellow, the second is violet, the third one is. So the first two numbers make this, and the third one is a multiplier. So we have yellow 4, we have violet 7, and we have orange. So orange will be the power, 10 power 3. So 47 kilo ohms will be the choice. If you have a 3 amps current flowing through the device, it should be having a 5 amp fuse, and the fuse should be connected to live wires. We have color coding, and we want to use this to calculate the resistance. Again, we have the first two as the numbers. So red means 2, black means 0. So 20 multiply 10 power red is again 2. 10 power 2 means 100. So 20 multiply 100 gives you 2000. Sorry, it is brown. The third one is not red, it is brown. 10 power 1 is 10. 20 times 10 gives you 200. Kilowatt hour. Thirty amp max is the socket. It's not the fuse. We have to think about the 0.5 amps. So from this choice, 3 amps will be the best choice. We can't use 5.5 for 0.5 because it might surge, the voltage might surge the current. Number 12, the diagram represents part of a household circuit. So wire W is a live wire because it has switch on it, wire X is a neutral wire, and wire Y is earth wire. Why it is dangerous to connect 5 appliances on the same socket? Because it will overheat the socket. Why the other ones are wrong? Let's look. The fuse blow? No, it won't blow because as long as the current is not exceeding the limit, it won't blow. Greater is electric shock. There can't be an electric shock. And overheating in each appliance will never overheat. It's the socket from where the lot of current is flowing will overheat. The fuse, the live wire touches the earth wire, and that's why the fuse blows. Other than this, all these choices, person touches a live wire, he will get electric shock because there is no circuit breaker here. It is the fuse. The fuse works on the rating of the appliance, not the man. A man touches the neutral wire, nothing happens. Neutral wire touches the earth wire, nothing happens. If the live wire touches the earth wire, that will cause a lot of current to flow through the earth wire. The live wire has fuse on it, so that's why fuse will melt down. 6 kilowatts of heater and it's connected to 240 amps. We will calculate the current. P is equal to VI. So the current will give you the rating of the fuse. That should be 30, nearest to the 30. Energy converted in 10 seconds. Convert it into multiply the power, multiply the power with time should give you the energy. So 36 times 10, 360. Mason heater is labeled this much. What is the current? So 60 watt divide 12 should give you the current, that is 5. Lamp is rated 60 watt. What is the current? Divide 60 by 240 gives you 0.25 current. P is equal to VI. Cost of electricity and 3 kilowatts multiply for 12 kilowatt hours multiply 12. So 3 times 4 times 12, that's the correct choice. The reading on the ammeter, well, 12 watt means the power is equal to VI. So both this should give you 12. So none of them except C gives you 12. That's why C is the correct choice. And 6 times 2 gives you 12 watts times 60, 720 joules. So power is equal to VI is to be used here, and then energy is equal to power into time should be used. So we have 0.25. The lamp does not light on because the live wire in the plug is not connected. Every other choice is not relevant. The earth wire doesn't turn on the lamp. The fuse 3 amps still works. The lamp works on AC/DC. Power supply, no. So if we have a 240 times 3 gives you, the appliance is 2 kilowatts. Okay, so the current calculated from P is equal to VI will be 2 kilowatt divided 240. That should give you the current. And this current will be greater than 3 amps. So the device will burn out. The fuse will burn. Which quantity is measured in kilowatt hours? That's the energy. Because charge, current, and power, they don't have kilowatt hours units. Switches of the circuit. The fuse will melt and switches off the circuit if it becomes heated because you're already working very close to the fuse rating. How does the earth wire prevent the electric shock? It allows a large current to flow to earth and that blows the fuse. Remember this for your knowledge. Batteries use 24 watts, 120 coulomb charge in 60 seconds should give you the current, and this current divided by the power should give you the voltage. So the student wants to find the faulty lamp. Where should he begin? He should begin anywhere because the current is same. So here you have to calculate the current by dividing 2500 with 240. P is equal to VI, and that should give you a current, and then nearest rating fuse will be used 13 amps. A wrongly wired plug. What is the effect of using plug wired in this way? So we have earth and live connected together. So that means because earth wire is connected to the body of the appliance, because earth is connected to live wire, so the body becomes live. The metal case is live. What are the correct colors of the wires? So we have brown on live wire, brown. Well, there's only one brown, so just choose B. Live wire is brown, and neutral wire is always blue, and earth wire is always green and yellow stripes. Which costs most? So you have to multiply the power with the time and you get the largest number in D. 0.1 times 24 gives you 0.24. A, because so if we have a short circuit here, fuse will blow, live will be disconnected, and we can repair the circuit. Every other doesn't give you this. We have the fuse on the neutral, and fuse is after the short circuit. So fuse will not. What's wrong in B? So if we have a short circuit here, so yes, the fuse will not blow in this because it is this side and this side. The short circuit will happen here, no effect on this side of the circuit. So the purpose of circuit breaker is to prevent the current from becoming too large. So the cost of dryer for 2 hours and with switch P closed and Q closed and R open. So remember the P turns the fan on which has 0.1 kilowatt. Add the power to Q which is 0.4 kilowatts. So it is 0.5 kilowatts. Then running it for 2 hours gives you 1.5 plus 0.5, 1 kilowatt. And then 8 cent multiplied gives you 8 cent answers. C is the correct choice. This question is repeat. Which pair of equation? Well, E is equal to VIT, we know that for sure, and P is equal to VI. We have done this before. So if something is carrying 5 ohms, something of 5 ohm carrying 2 amps, the voltage becomes 10 volts. Multiply 10 with 2 and then 10 gives you 200. That's the energy calculation using P is equal to VI relationship. Cost least will be 5,000 for 1 minute. So it is 5 times 1 over 60. That will be very less cost. The fuse fails. Third fuse, larger rating. Why it's not sensible? Because there is a problem in the circuit. Find that problem, resolve it. But for this, the circuit may work, but it is dangerous now. It will be, the fault is still there and it can cause any problem. You have to remove the fault and then replace use the same fuse. Do not increase the fuse rating. Next, we have this repeat question here. Other three lamps stay on. Which lamp, if melted, does not affect the other three lamps? It is lamp B, because if you disconnect this part, we will still have the current going all the way. The three lamps will still be on. Cost calculation, 2 kilowatt, 100 watt, 1 kilowatt of energy. How much electrical energy is used by the heater alone? So you have to work it out by calculating the total energy, and then the lamp is 100 watt, and in 1 week it uses 1 kilowatt. So subtract 1 kilowatt from here, and then you should get this answer. To be honest, the unit contains 2 kilowatt heater. How much energy used by the heater alone? Heater will, for 1 week, heater will use 20 kilowatts times, well, it's a tricky question, to be honest. Look at it again. A combined bathroom have a heater and a lamp controlled by one switch. The unit contains a 2 kilowatt heater and 100 watt lamp. If in 1 week the lamp uses 1 kilowatt of the electrical energy, how much electrical energy is used by the heater alone? Well, the electrical energy used by the heater should be 2 kilowatts multiply 7 multiply 24. If you multiply 2 with 7 and then 24, ideally you should get 20 kilowatts, the answer. So here electric kettle is plugged and switched on. The fuse is blows immediately, is because the live wire touches the metal case of the kettle. The every other choice doesn't work. In order to turn off both lamps, we have to place the switch here. 'So which circuit So we have earth connected to metal frame, and we should have live on the fuse and neutral connected to heater. What's wrong in the other ones? Neutral to fuse, wrong. Live to fuse, but connected to earth, wrong. And neutral to fuse, wrong. That's why D is the correct choice. So it should be connected between the live wire and the heating element. 5 amps fuse. We have repeated this question 3-4 times. And a small heater, 12 volt, 2 amps. Calculate power here, multiply with time, you should get joule. So P is equal to VI 24 times 5 times 60 should give you 72. Give.